Hi, everybody. Welcome to my channel, Numbers with Nora. This is a math tutoring channel where you can find math help for homework, tests, and also any other math needs that you may have. Again, I apologize about my voice. I've been a little sick lately, but we can get through it. For this specific video, we're going to be doing geometry, and this is going to be chapter 3. Parallel and perpendicular lines, and this is going to be a practice test. So if you are in geometry and you are on chapter 3, this could be helpful for you. The book I'm using is called Larson Geometry. I'll sit there and put the link to it. It's a free PDF in the comments to this video. But also, if you're using another geometry video, then you'll be able to follow along just as easy. So let's go ahead and start. I would advise you to pause the video when I show you these and try yourself and then see how I work it out. But I am going to sit there and be moving pretty fast because I want to sit there and try to finish the whole test in this one video. So let's begin. So questions 1 through 6. They want us to classify the pair of angles as corresponding alternate interior, alternate exterior, or consecutive interior. All right. So for number 1, we have angle 1 and angle 8. These ones right here are actually going to be alternate exterior angles. So we can view this as T. That's our transversal that cuts it. And then they're on alternate exterior sides of my lines. Okay. So 1 is going to be alternate exterior. Right. Like I said, I'm going to be moving pretty fast, so you can write down the answers for them as I go. For number 2, I have angle 2 and angle 6. Angle 2 and angle 6. These two angles right here are going to be corresponding angles, because see how they sit on the top of my parallel lines, and then also they sit on the same side as the transversal. All right. And then for number 3, we have angle 3 and angle 5. These two angles right here, they're going to be consecutive interior angles. Remember, in math, consecutive means one after another. Interior means on the inside. So I like to think of it as they're angles that like sit right next to each other or one after another, and they're inside of my 2 parallel lines. So 3 is going to be consecutive interior. 4, I have angle 4 and angle 5. These ones right here are going to be alternate interior angles. Because like I said, if you look at your transversal right here, that cuts the 2 lines. They're on alternate sides of my transversal, and they're on the inside of my other 2 lines. So alternate interior. For 5, I have 3 and 7. Again, they're on the same side as my transversal. And then they both lay on the bottom of my other 2 lines. So these are going to be corresponding. Okay, for 5, 3 and 7. And the last one, 6. This one is going to be angle 3 and angle 6. And again, they're both inside of my 2 lines, and they're both on alternate sides of my transversal. So they're going to be alternate interior angles. Okay. All right. If you didn't have time to write those answers down, you can go back and pause and write them down. So let's move on to 7 through 9. For 7 through 9, it wants us to find the value of x. So for this one, they do have labeled that these are parallel, so it's safe to sit there and use our theorems that we have for angles in parallel lines. So for this one, I notice this is my transversal that cuts my 2 parallels. If I look at this 40 degrees and this one right here, notice again, they stay on the same side of my transversal, and they lie on top of each of my parallel lines. So I know they're going to be corresponding angles. Corresponding angles are congruent. So my x is going to equal 140. 140. Okay. And then for 8, for this one, I sit there and see they're talking about this angle right here and this 50-degree angle right here. Again, they have our symbols for parallel lines. This is going to be my transversal. My two angles are on the alternate sides of my transversal, and they lie inside of my parallel lines. So it's safe to say that these are alternate interior angles. Alternate interior angles are congruent, so I can set this up as 50 equals 18x minus 22. I can add that 22 to both sides. When I add that 22 to both sides, I'll get 72 equals 18x equals 18x. Divide both sides by that 18. Sorry, that's a ugly 18x. And then for this one, you should get x equals 4. Okay. And again, these are all the right answers, and you can also check the answers in the free PDF download in the comments, okay? And for number 9, we look at these angles. This one's going to be a little bit trickier because these have no, oh wait, this is my transversal. These are alternate sides, and these are both outside. So this one right here, this 107, and this one right here. These are alternate exterior angles. So you sit there and see that they're on the alternate side of my transversal, and they're outside of my parallel line. So alternate exterior angles. Alternate exterior angles are congruent. So I can say 107 equals 4x plus 11. Okay. And so from there, excuse me, from there, I sit there and subtract 11 from both sides. And so I get 96 equals 4x. And then I divide that 4 on both sides. So when I divide that 4, I get 96 divided by 4, which would get me x equals 24. X equals 24. Okay. And that's just using basic algebra. If you are having problems solving these basic algebra equations, then let me know in the comments and I can make a video for algebra 1. Okay. Let me erase this a little bit so I can see. Now for problems 10, 11, and 12, we have to find the value of x that makes M and N parallel. Again, try these on your own and pause the video first before I sit there and work through these. So again, to make these parallel, that means that we have to find some kind of correlation between our angles. These angles right here, again, they're consecutive and they're inside of my two lines. So these are going to be consecutive interior angles. Remember, consecutive interior angles are not congruent. They actually add together to get 180. So the equation that we would set up here is 37 plus x equals 180. Okay. And then we would solve from here. Again, using basic algebra, I do 180 minus 137. X is going to equal 43. Right. And you can always check your answer by making sure that 137 plus 43 will give you 180 degrees. All right. Let's go on to 12. So for 12, of course, to make these parallel, then these two lines would have to have some kind of relationship. The relationship they have, if you notice, if this is my transversal, they're on the same side of my transversal and they sit on top of my two lines. So they're going to be corresponding angles. Corresponding angles are congruent. So I'll have 128 minus x equals x. And now I just solve for x. I'm going to sit there and add that x to both sides. When I add that x to both sides, oops, sorry. When I add that x to both sides, I'm going to get 128 equals 2x. I divide 128 by 2, and that's going to give me x equals, so I'm going to write it up here because I'm running out of room, x equals 64. Okay. All right, so let's look at 12. Again, for M and N to be parallel, I need these two lines to be connected in some kind of way. If I do look at these, I can't sit there and say they're alternate interior because the 73 degrees is outside of my two lines. I can't say they're alternate exterior because this one's inside and that one's outside. So it kind of seems like they don't have a relationship. So I'm going to have to depend on something else. What I can depend on is that this one right here, oh wait, find the value of x that makes, all right, what I can depend on is this angle right here. If I find this angle right here, then these two angles will have a relationship and be congruent. They'll be corresponding angles, again, because they're on the same side of my transversal, okay? And they're both this time beneath my two lines. So if I find this green area, then it will sit there and help me find my x. All right, so to do that, I can do 180 minus 73 because that angle plus my 73 degrees will give me 180 degrees. Okay. So 180 minus 73, that's going to give me 107. Now that I have this as 107 degrees, these are corresponding angles, so I could set these equal to each other now. So then I have x plus 17 equals 107. I just subtract that 17 from both sides. So I'm going to have x equals 90 degrees. 90 degrees. All right. All right. So let's go on. Let's do 13 through 14. They want us to find the slope of the line that passes through the point. So again, we're just finding slope. For those of you who have forgotten your slope formula, that's going to be m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay. And what I do on all my tests is I always like to annotate what I'm using as my y sub 1, what I'm using as my y sub 2, okay, what I'm using as my x sub 1, and what I'm using as my x sub 2. It just helps you so when you sit there and if you do make a mistake, it's easier for you to go back and check it, okay? And I would do that for 13 through 14. I'm not going to do it right now because I want to save time through this video. So for 13, let's go ahead and find the slope for that one. What we do is we just substitute in what we marked down. My y sub 2 is 4, so I have 4. My y sub 1 is -1. I put parentheses around it because I want to account for that minus. Okay. And then over my x sub 2 is 3 minus 3. Right off the bat, 3 minus 3, that means I'm going to get a 0 in my denominator. Mathematicians do not like 0 in the denominator, okay? We can't have that. So I know that this is going to be undefined. This is an undefined slope. Undefined. And something with an undefined slope is just basically a vertical line, kind of. Undefined. I'm not going to spend time explaining that. All right, so let's do 14 now. For 14, again, use your annotations, but just for time, I'm not going to use mine. I have -3 minus 7 over -1 minus 2. Okay. That's going to give you -10 over -3. Those negatives are going to cancel out. So my slope is just going to be 10 over 3. Okay. And that's for number 14. So now let's do 15 very quickly. Erase this. For 15, I have 12 minus 5. And then I have negative 6 minus 0. Again, if you annotate yours, you can sit there and do it quickly like how I'm doing. Right? 12, 11, 10, 9, 8, 7. I have 7 over negative 6. And that's my slope. I can't simplify that down anymore. All right. So that was just a quick review on finding slope. I'll leave the slope formula up there because for some of these, we're going to have to use it again. Oops. Let me go back down. Oh, there we are. Sorry about that. Was moving too quickly. Sorry. Okay. So now let's go ahead. Oh, is it going to let me erase? There you go. I can just cut it. All right. Let me start writing again. All right, so for 16, it says write an equation of the line that passes through the given point P and has the slope, the given slope M. So whenever they give you a point and slope, here's another formula I'll write on the side. It's going to be called the point slope formula. So the point slope formula is y minus y sub 1 equals M in parentheses x minus x sub 1. Okay. And the subs are what we'll sit there and substitute in for our point, and my M is just my slope that we'll substitute in. So let's go ahead and do that one first. We'll do 16. I have y minus, okay, that's my y sub 1. Again, on your test, I would say always annotate what you are plugging in so you don't make mistakes. So y minus 4, my slope is 3. And that's going to be multiplied by x. Again, I have that minus right there, so I'm going to put another set of parentheses to account for it, that negative 2. Okay. Now I can go ahead and simplify this down so my y is isolated. So I have y minus 4. I'm going to do 2 steps at the same time. I'm distributing this 3 to hit everything, so I have 3x. Again, a negative times a negative is a positive. So this turns into positive. 3 times 2 is 6. Okay. So then I'm just going to add 4 to both sides. I have y equals 3x plus 10. Okay. That's my line right there that passes through this point and has a slope of 3. Right. Let's go on to 17. Okay. For 17, I have the 0.712, and my slope is going to be negative 0.2. So again, let's go ahead and plug in where we need to. My y sub 1 is going to be 12. My slope, oops, my slope is going to be negative 0.2. And then my x stays there. That's part of my formula. And my x of 1 is going to be positive 7. Oops. Why was I writing a plus? Minus 7. All right, so let's go ahead and start by starting to isolate our y. The first thing I'm going to do is distribute. When I distribute that negative 0.2 through to hit each term, okay, I get negative 0.2x. And then plus, I have negative 0.2. What is that? Let me see. Negative 0.2 times negative 7. That's going to give me positive 1.4. Sorry, I had a brain fart. 1.4. Right. Then I want to subtract that 12 from both sides. So now I'm going to get y equals negative 0.2 x. And then I believe I'm going to get a negative. No, because I add that 12 to both sides, so plus 13.4. Perfect. All right. So that is my line that passes through this point. It has a slope of negative 0.2. Right, let's do 18. That will be our last one for using point slope form. And I'll leave the formulas up so you guys can sit there and have those as references as well. But the more you use them, the more you'll start to memorize them. So 18, this time I have a negative slope. So I'm going to have y minus my y sub 1 is 5. My slope is negative 8. And then inside my parentheses, part of my formula is x. My x sub 1 is going to be positive 3. That minus is part of my formula, so I put it in like that. I want to isolate for my y, but first I need, so I have y minus 5 equals negative 8x. Oops. My pen keeps on messing up a little bit. Sorry. Minus negative 8x. And then I get a positive because a negative times a negative is a positive. 8 times 3 is going to be 29. Okay. No, 24. My apologies. What am I doing? There we go. It's way better. So now I can sit there and add my 5 to both sides. I have y equals negative 8x. And then plus 24, 25, 26, 27, 28, 29. There we go. Now we have 29. I was jumping the gun. Okay. And so again, y equals negative 8x plus 29. That's going to give me my line that passes through the point 3,5 and then has a slope of negative 8. Right? So that was just a refresher on how to find the equation of a line given a point and a slope. So now let's go ahead and look at 19 through 21. This one says write an equation of the line that passes through the point P and is perpendicular to the line with the given equation. So remember, a perpendicular line to one line, it's basically going to have the slope that's opposite, meaning a sign change, and reciprocal, meaning we flip our fraction, okay? So we're going to be using the same formula, but instead of using the slope they give us, we are going to have to sit there and use the perpendicular slope to plug into our point slope formula. All right, so let's start with 19. 19, my slope right here is going to be 2. Remember, your slope is the coefficient of your x variable. So I want to find the opposite reciprocal of 2. Negative, and then I flip 1/2 is going to be my perpendicular slope for this line. Okay, so again, now I use y minus my y sub 1, which is 3 in this case, equals, I put in my perpendicular slope, which is negative 1/2. And then in parentheses, I have x minus 1. Okay, now I start solving down for y. I distribute this to hit each and every term. So y minus 3 comes along for the ride. And then I have negative 1/2 x plus 1/2. Okay, that looks about right. Okay, so then what I'm going to do is I'm going to sit there and add the 3 to the other side. So then I'll have y equals negative 1/2 x. We're going to have to do some fraction work. Plus, I'll do the fraction work down here. So I have 1/2. So I'm adding that 3 to other sides. Plus, I can make 3 look like a fraction like that. 3 over 1. I need to get a common denominator before I can add my numerators. 2 times 1 is, the common denominator is going to be 2. Remember, whatever I multiply the bottom by, I have to multiply the top by. Or you can think of just cross multiplying. So 6. And this is 1. So I'm going to get 7 over 2. If you need a refresher on fractions, adding or subtracting fractions, put a comment down below and I will do a video or send you resources for adding and subtracting fractions. So now we just found a line that's going to be perpendicular to the given line y equals 2x minus 1. Okay, let's continue. Next, we're going to do 20. Always takes a while to erase some of these. Okay. All right, for 20. Here, again, my x variable is being multiplied by a negative. So this is -1. A perpendicular slope to -1. Again, we do a sign flip, so we know it's going to be positive. -1 over 1, if we flip it, we just get 1 over 1 again. So we can just put our slope is going to be 1, right? So now we sit there and use our point slope formula to sit there and find our perpendicular line to that line. So I have 2, or y minus 2 equals 1 in parentheses. Oh, that's a big parenthesis, sorry. X minus 0. Okay. I distribute that through. My y minus 2 comes along for the ride. 1 times x is just x. 1 times 0 is just 0. I add that 2 to the other side, and y equals x plus 2. So this line is going to be perpendicular to that given line for number 20, right? Now let's go ahead and do number 21. Okay. For 21, again, for this one, it's a little different. I can't really right off the bat tell what my slope is. So it's always easiest to get your equations in y equals mx plus b form. So it's way easier to identify the slope. So let's go ahead and get this form into y equals mx plus b form. To do that, I'm going to subtract x from both sides. So I have y, negative y equals negative x plus 4. Again, I want to isolate my y. My y is not isolated because it's being multiplied by that negative. So I multiply or divide both sides by negative. When I do that, I get y equals x minus 4. Okay. Now it's way easy to see what my slope is. My x variable is just being multiplied by 1, so my slope is going to be 1. The opposite reciprocal of 1 is just going to be -1. Okay. I do a sign change and then I flip 1 over 1. It's just the same thing if you flip it. So now that I have my perpendicular slope, I can go ahead and put in my point slope formula. I have y minus, be careful with the signs. I have -3, so I put parentheses there. And then my slope is -1. And then I have x minus 2. So again, let's go ahead and do our distributing first. Distribute that negative through. A negative times a negative gives me a positive. And when I distribute that -1 through, I have negative x plus 2. Now I'm going to subtract that 3 from both sides. Ooh, that's a funky looking y, sorry. So I have negative x minus 1. And that's going to be my line that's perpendicular to the line given right here. Okay. All right. Let's continue. I think we only have a couple more. All right, so let's look at 22. For exercises 22 through 24, it says A and B is perpendicular. That little symbol right there in math means perpendicular to BC. Find the value of x. So remember, when two lines are perpendicular, they create a 90-degree angle, okay? So perpendicular lines, they create a 90-degree angle. So that means all these angles are going to be 90 degrees. So to find these, I can sit there and set up the equation 68. Oh, that's really ugly. I can't stand that. Let's do it like this. 68 plus x equals 90 degrees. Okay. Or you can just do 90 degrees minus 68, but I wanted to show you the whole equation that you set up just to get you used to setting up equations. So for this one, 22 is going to be 90 minus 68, which equals 22. Okay. 23 again, these are both going to equal 90 degrees, so 51 plus 3x equals 90 degrees. I subtract that 51 from both sides. I get 3x equals, what do I get? 3x equals 39. 39 divided by 3 is going to give me 13. Okay. So our x for this one will be 13. I'm pretty sure if you plug in 13, multiply it by 3, and add it to 51, you should get 90 degrees. Okay. This is our last one. Setting up this equation, I have x plus 8x plus, I got to see if that's a 9 or not, plus 9, just making sure. Equals 90 degrees. So this one, it would be 9x, because I add those x's together, add my like terms together. Plus, actually, I'm going to do that in one step. I subtract that 9 from both sides. When I subtract that 9 from both sides, I'm actually going to get 81. When I divide both sides by 9 to isolate my x, I get x equals 2. Or 9, my apologies, x equals 9. Okay. So that's going to be my value of x. That one was pretty simple. This one, the whole trick was just remembering when two lines are parallel, where they intersect creates a 90-degree angle. And let's go ahead and do this word problem, rental costs. The graph at the right models the cost of a renting and moving van. Write an equation of the line, then find the cost, of renting the van for a 100-mile trip. Okay, so first they're asking us to write an equation. This is a line, so to write an equation of a line, we need to know its slope, okay? I have the slope formula up here if you need to reference it again, all right? Just go back in the video and reference it, but I'm not gonna spend time writing out that formula again, all right? And the 2 points I'm gonna be using are these 2 points. Again, if you're on a test or even if you're doing your homework, make sure you annotate. I'm gonna use this as my y sub 2, so then I have 60 minus 30 over, I'm using this as my x sub 2, so 50 minus 0. All right. 60 minus 30 is just 30 over 50. I can cross out those zeros. So then I'm just going to get my slope is 3 over 5. Now that I have my slope, I can sit there and pick a point from this line, any point I want, and sit there and use point slope formula. Again, if you scroll up or rewind the video, I have the point slope formula up there with the other problems we did. The easiest trick here is if they do give you a point with a 0 or a y-intercept or something, always use that. It's always good to use lower numbers or zeros. So I'm going to use 0, 3, 30 as my point. So now I have y minus my y sub 1 is going to be 30. Okay, equals my slope that I found just now is 3 over 5. And then I have x minus 0. Okay, then I distribute this through because I want to isolate my x. I have y minus 30, which comes along for the ride. And then when I just distribute that through, I get 3 over 5x. Then I add that 30 to the other side. Okay, so when I add it to the other side, y equals 3 over 5x. plus 30. Okay. There's my equation of the line that helps model the situation that they gave us. So this is a two-step problem because they didn't only ask us to write the equation of the line, they also told us to find the cost of the renting the van for a 100-mile trip. So notice if we look at this, these are my y's. My y's are going to be my dollars or cost. My x's on my x-axis, these are going to be my miles, okay? So if they give me my miles, they're talking about my X, I just substitute in wherever I see an X, I'm going to substitute in 100. And then my output is going to be my cost, what they're trying to ask us for. So all I'm going to do is sit there and substitute in 100 into my equation, 3 over 5 times 100 plus 30. All right. I'm going to run out of time on this video, so I'm not going to sit there and solve this all the way out. So if I sit there and multiply 3 over 5 times 100, 3 times 100 is 300. 300 divided by 5, that's going to give me 90. Hold on, I'm having a brain fart right now. Sorry. 300 divided by 5, that's going to give me 60. And then 60 plus 30, that's going to give me 90. Okay. So the answer to this is for a 100-mile trip, you would spend about $90. All right. So we went ahead and finished all the tests. This was chapter 3 test. Again, I have the book PDF in the comments. So if you see something in that test review or any kind of questions from chapter 3 that you don't understand or need help with, put them in the comments. I will sit there and show you step by step how to get to the correct answer. I also put a website on there called Numbers for Nora, where you can request to get math tutoring or math help individually if you like as well. All right, so if you have any questions, please subscribe and leave your messages. Thanks.